Hello everyone. We are live, extremely punctual as usual with our IoT Sparks live webinar. Hello everyone. As usual, I wait a little bit, a couple of minutes to wait for people to join the webinar. And today we have a very interesting topic, something I'm also personally very passionate about. And yeah, as you can see already from the title, we are talking about, of course, IoT, but in this case, we are focusing climate resilience. We are focusing environmental monitoring solution, and we are, let's say, focused on the impact that IoT can generate. We also talk about this triple impact of IoT that it can generate positive impact in our finances, society, and the planet. This is a very very positive side effect very often of IoT, but in this case, and in use cases, the one we are talking about today, it's like the primary goal of IoT. So we use IoT because we want to protect the environment and so on. As a reminder for everyone that is joining, you have the chat, so you can anytime write your comment. We'll try to interact. This is a live webinar, so we'll try to interact live with your comment. And you also have a Q&A session, so you can ask your questions. We have a Q&A session at the end of the webinar, so we will leave the question unanswered until the end to not to interrupt our guest. And by the way, this is exactly the best time, so I can see people still joining. So again, welcome anyone that is joining us today for this webinar. Let me already start and let me introduce our three speakers that you can already see live and connected. They are three founders of them. We have Reinhard Bischoff from Switzerland. He is founder and CEO of Decentelab, an hardware company manufacturing a very high-level devices for IoT. Then we can see connected with the wonderful logo behind this his desk, Simon Kemper from Germany. He is also co-founder and CEO of Datacake, which is an IoT platform. It's a low-code IoT platform that is growing massively and is becoming very adopted in the IoT, say, ecosystem. And last but not least, Gunter Schobesberger. These are the surname, but I try to do my best. He's also founder because several years ago he founded a company called EcoSensors that was specifically focused on environmental monitoring solution. And this company was recently acquired by LORIOT. So now Gunter is part of our team in LORIOT and is responsible of this new division, basically keeping on building environmental monitoring solution under a new brand, LORIOT Verso. And so is the best person to approach this topic today. Again, we are talking about environmental monitoring, and we will discuss what it is, why it is important, what are the risks now, and we'll go through a very nice use case about wildfire detection and prevention solution, and we will have an outlook on what are the component. And of course, you can already imagine, starting from our speakers, what are we talking about? So yeah, without any further ado, I hand over to Gunter, who I ask to take control, and I'm asking the other two speakers and myself. We're gonna switch off our microphone and mic, so the audience is all yours, Gunter. And yeah, let's see. Let's meet again at the end with a Q&A session, and see you later. Enjoy the webinar.
Thank you very much, Dario. Thank you very much for the nice introduction. So today it's all about environmental monitoring. And I have the pleasure to present LORIOT Verso. So it's the new business unit, what already Dario explained, which is focused on IoT environmental monitoring. So just that we all understand the same. So what means environmental monitoring, and what are we talking about today? So in general, we can say the nature or the environment is talking to us. So it's communicating with us. And how does it do it? It does it via data. So it's sending constantly data, and we also only have to listen to this data. So what is environmental data about? So in general, we all know, of course, climate and weather data. So the typical ones like air temperature, like humidity, like atmospheric pressure, also wind direction, for example, or wind in general, precipitation, also very typical one, rainfall, for example, also snowing. Then also lightning, radiation. So a lot of data related to climate and weather. Then we have environmental data in general. So that means the environment, the nature regarding soil conditions, for example. So we are talking about soil moisture, temperature, conductivity, a very important topic regarding the environmental monitoring. Also, for example, a classic one is air quality or water quality as well. And then we have like a third section, let's call it like this. It's everything what is surrounding us, or what are like the consequences of these environmental data. So this is, for example, icing on the street, or it's, for example, the heat stress in the cities, or, for example, very important topic, which we are talking later a bit more into detail, about wildfire risk in general. Yeah. So derived from this environmental data, we have these three sections. And if we move on, we just should talk a bit about why is environmental monitoring important. So why do we do it? So it's just for fun, or why do we do it? So you all know that we are living in a constantly changing world. You know about climate change. You know about changing in general in the environment regarding our nature, and that's why it's important to listen very carefully to what is the nature, what is environment talking to us, or which signs is it sending. And that's why we decided with LORIOT Verso to give our environment a voice. So this is our mission, which drives us. And you all know that extreme weather events are increasing rapidly. We also have the problem with energy and resource shortages, also very important regarding this environmental monitoring. Then we have regulations like the ESG, climate and environmental protection. Also, health issues are increasing, related also to the climate change. And then, of course, the big topic, biodiversity, is changing a lot. And there are like 4 or 5 big reasons why we should, or we have to do environmental monitoring. And then what is the consequence of the climate change? So we are talking about today also about natural hazards. So I brought here a slide, and you can see on this presentation, on this slide, a graphic which shows the typical natural hazards of Europe. Yeah, because of course in South America or in China, for example, you have different natural hazards as well. But if we talk about the mid of Europe, then we have the big problem with floodings. So big portion of this natural hazards is regarding flooding. Then, of course, extreme weather events, but also in the context of climate change, drought is increasing rapidly, and also the fire risk. So not only in Spain, in Greece, and Italy, this risk also comes more and more to countries like Austria, to Germany, to Swiss, and it's getting more and more a problem. So now the question is, how do we face these challenges, and how can we adapt? So the good thing, humans always in the history were very good in adaptation. And the thing is, you cannot adapt or you cannot improve nothing what you can't measure. So that means that we need data, and this data is often lacking. So it's often not there. And I brought here a quote of Mr. Niedermoser. He's our partner in the Austrian Weather Service, and he also mentioned that there is a lot of data, but when it comes to small scale data, then often there is not the data we need. So this is the challenge: no adaptation without data. And when we are talking about data, then of course we are talking about IoT. So IoT was developing a lot, as you all know, in the last years with new technologies. And so the good thing is we can bring this technology into the field of environmental monitoring, because you have to imagine if you are measuring like the level of a river or the drought of the soil in the woods, you all often don't have infrastructure, you don't have energy, you don't have connection to internet or whatever. So you need the right technology. And that's perfect for IoT. And IoT is or could be also in the future the game changer in the environmental monitoring, because you can send data via very long range. You have low power devices. So all these advantages are perfect for environmental monitoring. So it's like predestined for environmental monitoring. And now that's exactly where LORIOT Verso comes into place and into play, and exactly what we are doing. So it's all about measuring and collecting data. It's about transmitting this data from the sensor, for example, from the wood, from the forest, from the field, wherever, through LoRaWAN, through MyOT, to the next gateway. And then from there it goes to internet, as you all know, to the network server. And then you can start to work with this data, processing this data, visualizing the data, and doing dashboard. I will show you some example about very high quality dashboards as well from the Datacake later on, and also leveraging the whole use cases. Our mission is to help our clients, like for example cities or communities or big companies, to adapt to the climate change. So this is our big mission, and of course, as LORIOT always does, with a full and a high quality approach and a customer focused service. So we want to help adaptation to make possible adaptation to climate change, natural disaster prevention and prediction, building resilience towards environmental change, and the very fast and reaction to extreme natural events, because this is very crucial if you want to save, for example, lives. Just to conclude, what we are doing is the whole full service approach. So from the consulting to the project management, delivering the hardware, the software, so everything that to be the focal point for our customers and to fulfill projects and to solve their problems. And we do it with our partners, and two of the partners we brought today to the webinar, and they will present their solution later on. But before, let's go into deep a bit into a very special use case, and where we have a very special solution and also a project we are at the moment developing. And that's the use case forest fires, wildfires. So as you all know, they are becoming a more and more big problem. And I brought some numbers with me. So imagine every year worldwide, wildfires causes 33 million death humans, causes 140 billion of US dollars on property damage, and also 3 billion dead animals. So a big problem. And the problem, which is even more a problem, is 90% of all these wildfires are caused by humans. It's not the lightning strike, or it's like the breaking out of fire without action. It's 90% humans, by doing barbecues, by throwing away cigarettes, or also doing or letting break out fires like with an intention. Yeah, so very, very bad. And the climate change is acting like a fire accelerator, let's call it like this. So that means the risk increases sharply. So we were thinking about, we have to bring a solution for this problem into field. And there are some solutions already out there in the IoT world, which are trying to detect the wildfires on a very, very early stage. Yeah, detected by smog or detected by camera systems or whatever. But for us, it was not enough. So we wanted to go one step further. So our mission is, or our idea is, not to let break out a fire. And how can you do it? So by predicting wildfires. And that's a use case I brought here. It's about real-time information about the wildfire risk situation on very specific locations. I will show you some impressions now about what we did, and then I can explain it a bit better. But the idea was to enact like a forest fire ordinance, to give them data and to give them a tool to predict fires much more precise than they did it until now. Because until now, they always did it without data, only from their experience. And what we are doing in this project, and in June, we will also develop it even more in Salzburg, in Austria. We have a project there. We are bringing out weather stations and soil sensors, measuring data about the climate situation regarding temperature, regarding the rainfall, regarding the soil condition. And from this data, we are calculating a fire risk index. So there are international recognized indexes regarding the wildfire, and we are using this one to calculate the risk index on a very specific location. Because until now it was only done on the large scale. Now what we are doing, and that's the game changer with IoT, we can do it on a very small scale. Let's go through some impressions that you get a bit more idea about this project and how we did the setup. As you can see here, we are here in the forest. We are here in the woods It's a valley in Austria, in Salzburg, in the community in Salzburg, and we were installing sensors of Decentelab and bringing out also gateways to have the connection. Why this project worked with LoRaWAN, and we are sending data constantly out of the woods from the trees directly. They are talking to us in real time and sending the data on a more or less there are 5 to 6 kilometers via LoRaWAN to the next gateway. So here are some more pictures that you can get a bit insight. We are sending data at the moment. I think we're about 15 minutes sending constantly the data, and this data is processed to a wildfire index. And now I brought also some visualizations and the dashboard for you. We will go into deep the dashboard and the technique behind later on in the presentation of Datacake, but just that you get a broad insight how this looks like. So we have here a dashboard for each of these locations where we installed the sensors. We are calculating this fire risk. And you can see here the graphics. So everything here is in green, so no problem. If this number is changing color, for example, to yellow or even red, then that means that the fire risk is high. Yeah, and that has the consequence that, for example, the Salzburg has to bring out warnings to the population. Yeah, and to inform them that they have to take care regarding barbecue, for example, or if they are moving in the nature. So we bring out warnings, alerts. We can do a lot of thresholds. So there is a lot of possibilities what we can do with the platform. And yeah, just to go through a bit, like the dashboard and visualization, you see here some examples of statistics, and you can see here the red line on these graphs. It's the fire risk. And it's always regarding the different parameters like precipitation, air temperature, like the wind speed, and you can see how it is changing constantly, this wildfire risk, depending always on the parameters about the environmental data. Also here, just to conclude, another example of the visualization. And what you can see also is we also are monitoring not only the fire risk, we are also monitoring the sensor. So because you have to imagine the weather station is mounted, installed on a tree, and it could fall down. You know, we are out in the nature. We are this is a harsh environment. So, but in order to know when it falls down, we are also monitoring the sensor. So we know exactly if it's straight or how much battery voltage it has, and so we are constantly monitoring. So this is just a bit introduction, a small short overview about the wildfire risk and environmental monitoring in general. And now I would like to hand over. I think next one is Reinhard Bischoff of Decentelab, and he will continue with the high quality devices. So for my part, thanks for the moment. And Reinhard, I think you are next.
Okay. Hello, everybody. And from my side, welcome to the webinar. So a short introduction. So who is Decentelab? What is it all about? So we say we are the wireless sensors and LoRaWAN experts, especially LoRaWAN experts on the devices side. Decentelab was founded in 2008 and so has now almost 16 years of experience. Our mission since whenever we started was about to make smart, wireless and autonomous operated devices, and that from the beginning with a focus the outdoor environment, for the harsh environment. So that's our focus on where we are going for. So it's all Swiss made. The engineering is done in-house by Decentelab, and the manufacturing is happening in Switzerland. So next slide. So here we have a lot of products, a lot of, as you can see, environmental sensors, where we are using in different kind of applications. So I made some categories. We don't go one after the other. You see a lot, like one of the main sectors are in the water-related use cases. So it's all about the water cycle, a lot about water levels, from wells monitoring to heavy industries to groundwater. It's level, and also we have several relevant water quality parameters where we supply relevant devices. Then the second category is about like everything kind of parameters we capture, like from air or is in contact with air. We have all the climatic parameters, like from a weather station, but as well some related to air pollution and road surface and more, which I will select some in the next slides. And as mentioned already by Gunter, also soil, and not only the soil, but we have also relevant parameters we can capture with our devices from the plants itself for different use cases. And then we have some special devices as the last category, which were hard to categorize. I will shortly talk about our weather station, the DL-ATM41, which was used in that project in Salzburg. So it's an 11 parameter weather station, and it sends the data over LoRaWAN. It captures the most relevant 11 parameters, climatic parameters. These are precipitation, the solar radiation, relative humidity, air temperature, and also really relevant is wind direction and wind speed. The device is autonomous powered, so it has the batteries inside. And with all of our devices, we focus to have a simple way to power the devices. So these are simple alkaline batteries so that you can deploy them worldwide and easily replace batteries if needed, and so keep a low maintenance, and even as when you're very remote, still easy to do. In this picture you see here, this is an installation in Mozambique where we provide this equipment as part of a large farm management system. But we also use that in city and urban heat islands use cases. It is very, as you can see, a compact weather station. You often see otherwise some weather stations which have different kinds of arms and sensors attached. So this is also mechanically very robust, which makes it very a favor for many installations where it meets the requirements. So the second probe is the soil moisture and temperature profile for LoRaWAN, the so-called DL-SMTP. So this device can measure in every 10 centimeter down to the soil moisture and temperature. So on the picture you see also here this installation of this plantation farm in Mozambique. There it's more about tree irrigation or safe water and increase the yield. This as you can see on the picture or also on the product shot, it has to be very durable, because you want to have this sensor in the soil for more than 10 years without maintenance. So as you can see, it's a solid and rugged sensor. and we have that also up to 160 centimeters profile. So if you have deep-rooted plants or trees or vineyards, you may want to know not only the surface water content, surface soil moisture content, you want also to know the lower levels. When we come to the fire risk, as mentioned in this use case, it's more relevant on the surface level than rather on the lower level. But you want to know a bit the profile because it provides you some information about the water flows, soil moisture changes. As a third device, which I kind of selected based on fire risk or on this use case, is our DL-PM. It's a particulate matter device, so it can measure fine dust. Beside that, it does also measure temperature and humidity, barometric pressure. So the main purpose is to measure PM1, 2.5, PM4, and PM10. So this is used, like, can also be maybe relevant for fire like an alerting, because like the smoke does quickly move forward, and you may see an early signal of a fire. And the particulate matter is a very easy to record or also long-term stable sensor to measure that, and maybe an early warning in case of fire. On the other side, it also helps to assess damage to the agriculture. So we have seen that this is used, this particulate matter sensor, around where it's relevant about forest fires, because if you have nearby vineyards or fruits, such smoke will be on the layer of fruits, which will give a huge impact to the quality of the fruit, or even can make it unusable, and so it may give you indications about the impact of such smoke, which can be quite far away, even further away, when we see these fires, which happen, for example, in California and other locations. So, as I said, Decentelab was from the beginning going to the field, or our devices are engineered to be used in harsh environments. Here you see like 3 pictures. 2 ones are a bit, let's say, very nice setups and installations in the field, where we are measuring with a dendrometer the stem growth of the tree, or also in that relation the stem shrinkage of the tree, because if forest is affected by drought, it cannot put back all the water to the tree, and so you see even a shrinkage during drought, and so we can assess also a fire risk by using the dendrometer. On the right side, on the very right side, you see when devices have been in the field for 5 or 7 years, so they are then exposed to UV radiation, to condensation, to temperature changes, to snow and ice, and when we're then more in the cities, you also then to like corrosive dust and more. But that's what we want to provide, reliable devices for such environments. That's where Decentelab has its focus on mechanically strong and on the electronic part. As Gunter also mentioned, like the flooding is one of the biggest natural disasters, and that's why we also have a lot of water level sensors. So we have that in various ways we can measure the levels of the water. So open waters like rivers and basins, and like channels where we have in the cities to move away in case of heavy rain events, the ultrasonic measurements, but we have also the groundwater measurements, which is also relevant asset, the ground, to control the groundwater and to maintain the groundwater table. And we have on top of that also laser-based or lidar-based water levels or snow levels. Yeah, which so as you can see, Decentelab focuses to be always present in the environment with its solutions. When I talk about in the field, I want to showcase you in this slide our one of, let's say, I would say, prototype device which we installed in 2017. And you can see there we measure the data every 10 minutes, and we transmit the data to the LoRaWAN network. And on the lowest part, you see the battery discharge. When we measure every 10 minutes and immediately send the data, the batteries really last in real environment with real values for more than 7 years. Here we even include the CO2 sensor, which is quite a demanding from an energy budget sensor. Yeah, I think it shows that we focus on reliability and very low maintenance costs. So what we bring out is really proven to be in the field for long and can be unmaintained on at least electronics level. Yeah. So with that, I come a bit to the conclusion. We, as Decentelab, are experienced in the field. We serve customers which are above Arctic Circle, where we are facing like -45 degrees. We are also on the other side serving devices where it's more like 50 degrees plus in very arid and very dry environments, or even also in the Amazon where it's very humid and other challenges. With these inspirations and glimpse to what we do in the field, I hand over to Simon, and we'll pass over to Simon.
Yes, thank you very much, Reinhard, and also Gunter for this exciting part of the webinar. It's quite impressive to see the battery life, actually. That is a really interesting. Excited to see that it lasts for so many years, which is a heavy argument because of sustainability and battery changes and so on. Great to see that. Just let me take control over the presentation, and I'm now able to switch up to my presentation. So yes, thanks also for participating in the webinar. And my name is Simon. I am the co-founder of the Datacake IoT platform. We actually started our company back in 2017, and in 2020, with the rise of the COVID crisis, we decided to turn Datacake into a software as a service only platform and opening up the integrations for LoRaWAN especially. And since then, we have been scaling our platform to over 20,000 users around more than 50 countries in the world. And our platform is being used by various kind of use cases. And one of those use cases we saw today, which was implemented by Gunter. He also brought a little bit more detail on how or what kind of dashboards he created on Datacake. And my part today is to explain you a little bit more about how we achieve that people like Gunter and manufacturers like Reinhard from Decentelab can use Datacake for their devices, business ideas, and so on. First of all, let's start with the integration part. So we offer integrations for various kinds of IoT ecosystems, and LORIOT is one of those ecosystems where we have a native integration for. Native integration means that LORIOT provides the LoRaWAN and now also my IoT network server. And you can integrate this into Datacake very easily by selecting LORIOT from the list. And we support both uplinks and downlinks for this integration. That means you can use Datacake to build control interfaces, to control your sensors. not just only visualization, but also send commands back to devices in case you want to reset them, control them, set parameters, and so on. One of the things that makes it also especially easy for first-time customers is that all of the customers that start with Datacake we are supporting 5 devices for free. They are fully featured, which makes it super easy for first-time users with IoT to get started. Simply get yourself a sensor, create an account on the LORIOT site, and then hook up everything to Datacake, and you can get started with the first devices and build your dashboards. Speaking of dashboards and data visualization, heading over to the next slide, and here it gets a little bit more in detail. So you can see on these 2 screenshots, which are basically the same that Gunter was also preparing. But I don't want to talk about the application. I want to talk a little bit more about the generic, let's say, use or style of Datacake. So we call ourselves a low-code or sometimes even no-code IoT platform. That means if you are probably familiar with website editors, you can basically click and create your dashboards. That means you can add your sensor devices. And for example, in combination with Decentelab sensors, we support their devices as a template. So you pick your Decentelab device from the list of supported templates, and then you add this to the platform, to your first 5 free devices, and you immediately get a dashboard that's showing the values coming from the sensor. And on top of that, you can build your own dashboards, which are like workspace dashboards. These are global dashboards. And for example, in Gunter's use case, he was using this feature to create such an overview, as you can see here, which is the forest fire risk demo. And you can combine multiple sensors into a single view. You can have a map view, display different kinds of things on the map, and then also build some custom KPIs, all without the need of any coding at all. It's simply drag and drop and plug and play. And this is the concept of the whole Datacake application. Moving on to the next slide, this is also an important element because today we were talking about the notifications, and for sure, if you have an IoT installation, a dashboard is a nice feature. And Datacake often is referred to as a dashboarding tool, but we are way more than just a dashboarding tool. And for example, one of the things that we are also very good at is rules and alerting. And in this case, we especially designed our rules and alerting engine based on the customer requirements and also based on deployments where you have not 10 sensors, but hundreds or even thousands of sensors. And the rules and alerting engine, this can be used with the same style, like you click and create a couple of rules. It's very similar to the if this then that tool, a popular tool from the internet, and you basically select one sensor or a group of sensors, and then you set something like the threshold for a temperature value, for a fire index. Reinhard was showing us some level sensors for water fillage, and you can also monitor the fill levels, and then you can basically define a couple of conditions. You can link different conditions. And then last but not least, and this is the important part, is you can set actions. And in actions, you can easily set an email action, a webhook, or an SMS, where you can send SMSs to your colleagues, employees, and you can send emails also for reporting, or you can use the webhook feature to hook up things like Microsoft Teams, Slack, or external data storage. And this is quite useful for larger scale deployments because basically you don't want to have somebody staring at the desktop or at the monitor 24 hours just in order if there's a wildfire index going out of control to notify somebody and call them via telephone. What you want to do is you want to set up an automated system. And as you could see from the Decentelab sensors, these sensors are working for years. And you can combine them with a clever alerting. That means that everything is under control. You can also have online, offline notifications if something goes wrong, but basically you can create a monitoring solutions with these tools without any programming. And you basically get a notification via email, SMS, whatever you want. And this is one of the tools that we also provide. And also actively, this is available for those 5 free devices. So you can play around and test around with that. And as mentioned before, Datacake is simply not just a dashboarding tool. If you, for example, have a company and you want to use LoRaWAN devices, or you want to offer modernized digital services based on IoT and IoT devices, you simply can use Datacake to create a first POC, for example. And then we also offer a white label package. And this white label package allows you to set your own logo, set your own company domain, and you can host the Datacake platform more or less on your own domain. This means that Datacake steps back, and customers, you can reach out to your customers and say, like, we've got this new IoT platform. They see your logo, your branding, and basically can present the whole solution to your customers as your own. In the case of the wildfire prevention, this would have been possible, like Dario said at the beginning. Gunter was starting as Echo Sensors, so Echo Sensors or even LORIOT Verso can now create a white label page to start their own company based on the Datacake white label. So this is something that more or less describes Datacake. So we are not just a dashboarding tool, but we basically bring the whole stack of IoT features that you need to provide an IoT solution. And this starts from the integrations part up to device templates and the data visualization, but then also rules and alerting. And last but not least, you can create your own solution using the white label site. And yeah, I invite everybody to test it out, because as I mentioned, you can just start right away with it. This is everything from my side. I would like to hand over now to Dario again, and I'm going to switch myself silent and turn the picture off.
You can stay, and I also invite Reinhard and Gunter to join us as we are coming to the end. Thank you guys for the amazing presentation. Regarding your last thing, Simon, let me also, it's a great invitation. You have a free account, and at LORIOT we also provide a free account of our network management system, or for LoRaWAN is a network server. So no excuses. You can sign up for free both on Datacake and LORIOT, and you can start, say, playing and experimenting and learn about the potentialities that we have. I can see already people writing. I hear also another comment that was this battery life 7 years is outstanding, with 10 minutes interval is really amazing, no? Of battery life. So congratulations. And about this, we already have a question in the QA session. So I remind everyone they can write their question in the QA session or in the chat as they prefer. And the question is, how do you run battery at -40 degrees? This I think it's quite a shared doubt, no?
Yeah, so like we have proven records, like online, even public data. But one of our customers hunting for these frost hollows for the very cold. Coming back to the question, and yeah, it's all about like making the device like the layout and the components and the circuit balanced. So balanced also that you have no current peaks, no voltage drops. This means, yeah, a lot of layout and a lot of expertise and optimizing the different parts. Yeah, so it's the same about sensor conditioning. If you do not just connect the sensor, but you have no proof that it's always super set up, you get measurements, but they might be wrong. And that's the same for the power consumption. If you're very balanced, it's easy for the battery to always provide through the chemical reaction the enough power, no peaks.
Yeah, luckily enough. Oh yeah, sorry, it's true. I take control and check. Yeah, it's true that your devices, they work in very extreme conditions, like Arctic, minus 40 degree, plus 50 degree. They work in forest where they are like on their own for years. Hopefully nothing happened in the meantime. They can fall down, as Gunter said before, because if they're in a branch or an animal, touch it and they can fall in ground. Or yeah, it's well, you have with your company 50 and plus years experience, but it's still something you have to research to improve your sensor, or it's like you have done your research, you know your shit, and now you just do it the best you can.
No, it's yeah, it's never stopping as in software development, but also in hardware. We have some improvements in our circuit, making it mechanically more stable or even further reduce the power. And so it's we are in a continuous development. And maybe one of the weird things is we had a tree which was falling down in the field, but the sensor kept on the tree, and so we were even able to monitor the stem growth, the stem changes in the diameter of a dying tree. So sometimes suddenly, yeah, such things suddenly will become some new data. Yeah, so we are coming up with new devices and also with a new generation. Let's say, like internally, yeah, you need to go. There are new chips, there are new things coming up.
Great, thank you. We have another questions here in the chat from Lars. He asks, Gunter spoke about alerting. Are LoRaWAN 10 minutes intervals enough, or would the use of LTE-M be better?
Well, I think there are two questions in one question. One thing is the alerting and 10 minutes. The thing is the risk prediction or the risk index is always calculated once a day. So this is a international standardized risk index and process, and it's always at 12 noon UTC, time zone UTC. So it's always calculated like this. So to have the risk or the fire risk more precisely, you don't need shorter intervals. So you don't need 5 minutes or whatever. So it makes no sense. The other thing is we are working with LoRaWAN in this project because we have the sensors directly in the field. So in the woods, there is no connection to interview. You have no to internet. You have no mobile reception. So that's why we are working with the gateway. We installed the gateways and also the sensors to have the possibility to get the data out of the forest. So, but for alerting, with this system, it's not, you don't need interval which is shorter. I hope this
Yeah, thank
is
you.
okay for the
we have more question coming. I'm very happy about that. One thing about this alerting, because alerting is in a wildfire detection system is key, because if you get the alert, of course you want to prevent, and everything has been built to prevent. So when the risk is higher, as you said before, the forest manager can, for example, inform people going there to be extremely careful because the conditions are very high risk for fire. But it's also important if fires occur that an alerting is thrown straight away, because they can provide a quick response, which is also sometimes very important, because sometimes the fire is much more uncontrollable, not controllable when it is peak. But it's also important, the alerting functionalities, to check that the sensors are still working. And so in this case, also it's important to receive alerting, not just for the fire, but also for the, let's say, the infrastructure maintenance. So there are two aspects. So there are other questions. One is from Veronique. Is there a Decentelab? So it's for Reinhard. Is there a Decentelab sensors planned that would detect the early stages of a forest fire? This is a question. And another question is always for you, because this battery was. And there is another question here. Is there a sensors plan to include visuals and acoustic for a more holistic monitoring of the environment, for example, biodiversity? We have these two questions. I don't know, to address one for Rainer for sure, the other, I don't know, maybe also Gunter.
Gunter, yeah. I do the first question. I think one indicator, early indicator for an alert, like of an immediate fire, can be particulate matter. Not sure if this is really complete. Like with the wind, smoke can let's say traverse fast, and so you may sense a peak in the smoke, or like in the particulate matter sensor. But there are some others like concept and ideas to use also what you have in the fire alarms in the buildings. It's tricky because you want to cover huge and large areas for fire alert in the incident of a fire. And I think there you have really, you have to combine several things. And I think one is for sure also imaging, satellite. I think there's much, and we can add one or two of these devices which are relevant, but I think this is more holistic. But this brings it to the next question, to Gunter.
Yeah, thank you. And another question for you. I've seen you have already answered. Here it's do you use full compatible LoRaWAN on your sensor with 7-year battery endurance? Yes, of course. I can read the answer here. They are, of course, fully compatible with LoRaWAN. Gunter, you wanted to add something on the other question?
No, it was just regarding this, what Reinhard explained, the difference between the fire risk index and the pure detection of the fire. You know, because the detection of the fire, to be honest, is very difficult. Because as Reinhard mentioned, you have a huge area, you have the forests, and so you need, there is a solution out there, and they are bringing out thousands of sensors, like smoke sensors, very small sensors. So you need thousands of them, or 10,000 or 100,000 or whatever, because to give a more precise detection. So there are other systems with satellites, with camera systems. So this was not our first approach, but we are thinking about this as well, perhaps to combine these two topics. But at the moment, it's more about the prediction.
Thank you. Another question, well, it's not a question actually, is Lars is telling that he asked the question before about LTE. He asked that to precise that he was thinking about flooding or extreme weather. In probably more urban area, not less isolated and disconnected. So do you have an answer for him, or still LoRaWAN is a good option anyway?
Should I maybe mention for the flooding? I think we have like catchments where you measure several small creeks which go into a larger water body like a river. So you measure upstreams the levels, and you also what we have when we have that also in our sensors. You measure more internally, and if it's a threshold reached, you then immediately send. So such things are possible. So you are more than like a reaction time of 2 minutes or so, which is still feasible in LoRaWAN environment. And then we have also the early warning And I think it's also a prediction of the flood from further away, what happens then downstreams. So such scenarios are already implemented by customers, and also have like this one, we have also minimal edge process. I would not even say edge processing, but yeah, simple things. So which makes then also used to do alerting. Yeah, and I think there's many things getting together for alerting.
Yeah, it's every use case is very complex, and for us as well was a challenge, because we were used to provide the network server, this network management, but now going with LORIOT Verso on an end-to-end perspective, we are taking care of all these difficult. The planning, for example, is very important. Where to locate the sensors to cover area, where to locate the gateways and so on, how to configure and the platform and use the right algorithms. So it's very complex. So it's always good to, let's say, rely on experts. And we have one last question. I said one last, not because they might not come others, but because we are running out of time. And the question is from while I'm not sure about the pronunciation. Sorry if I get it wrong. Do any of the sensors used in environmental monitoring require periodic recalibration during their lifetime?
So that's for me. Some are have a need to that they're recalibrated periodically. We try, like in the IoT, often to look at the use cases where you can use long-term stable sensors. But I have the counter example of like a bad but very relevant sensor is the pH. So to measure the pH value in the water. Unfortunately, there's no better principle that you have to. It's like with a chemical reaction, but you have to calibrate that every like 4 or 8 weeks. That's about sensors or how you can assess such a parameters. But I think we always look to that we do especially implement sensors which you can ever leave in the field unmaintained for many years, or say once a year, where you have to go to clean or maybe cross-check locally, like local inspection. I think their IoT has the biggest let's say, potential, yeah, to bring value.
Yeah, indeed. Thank you very much. Thank you to our audience. Let me finish with the usual stuff. So, well, first of all, if you're interested in the environmental monitoring, let me share with you an article written by Gunter. It's our blog, and talks about the risk and what environmental monitoring is all about. And then, as usually, let me invite you, completely different topic. We are talking about infrastructure and infrastructure monitoring. Our next free webinar, it's on the 11th of June with our partner Move Solutions. And last but not least, let me remind you about our event, our IoT Congress, IoT Sparks. This is in September, Valencia, but also online. And let me thank you, our guest here, our speakers, Simon Kemper from Datacake. Datacake, by the way, is also one of the sponsors of the event we are holding in September. Reinhard Bischoff, Decentelab, and Gunter Schobesberger, always difficult for me, from LORIOT, and from myself. Thank you to all of you for participating. And as usual, we also share this webinar, the replay, in the next day, probably tomorrow. You already find in our YouTube channel. So follow us. And as usual, I invite you to connect with our speakers and myself from LinkedIn to continue the conversation. That's all. I see Well, one person raised a hand, probably was time to say bye or to clap the hands, as I can see. Again, thank you to everyone and see you next time.
Thank you.
Thank you. Bye-bye.
Thank you very much.
See you
Bye-bye.
soon.
Bye.